What we're actually looking at are tiny dust grains from a comet, and this comet is called Swift-Tuttle, and it takes about 133 years to orbit the Sun. Now we're also orbiting the Sun, and at the same time every year we plough into part of the cometary debris, the trail that's left behind this comet as it makes its journey around the Sun. And as that happens, we see lots of little bits of this comet plough through our atmosphere, and they flare up, and we see these gorgeous huge bright streaks. The reason why they're so bright is because there's so many of these bits of cometary dust. We're ploughing through quite a high density region of this essentially the vapour trail of the comet, and we're ploughing into that part of the trail at very high speed. So we're seeing these bits of dust entering our atmosphere at about 60 kilometres a second. And as they do that, they interact with our atmosphere and give off a lot of light because of friction and lots of other processes that are happening. So this is what we're seeing, these little bits flaring up as they enter through our atmosphere. The majority of these bits are incredibly small. Some may be as big as pebbles, but they do all burn up in our atmosphere. So we're not going to see any bits reach the surface of the Earth. You may have heard of meteorites, that some of these do travel through the atmosphere and reach the surface, and we can pick them up and we can analyse them. But meteorites originate from a different part of the solar system. They come from a region called the asteroid belt, which is a huge ring of rocks, which are very separate to comets.